Welcome you all. In this session, we are going to discuss the need for system planning and operational studies in power system, power scenario in India, power system components. After successful completion of this session, the student would able to explain the various planning and operations in power system, and student would able to explain the current scenario of power in India. Let us discuss one by one. Needs for system analysis in planning and operation of power system. Planning and operation of power system. Operational planning covers the whole period ranging from the incremental stage of system development. Maintaining a reliable quality economic and secure power supply by carrying out periodic planning and operational studies. The system operation engineers at various points like area, space, regional and national load dispatch of power. These studies stimulate the behavior of system under normal and abnormal operating conditions that the system may undergo to reversal any system inadequate either during steady state or during transient period. Power system planning and operational analysis covers the maintenance of generation, transmission, and distribution facilities. Planning, implementation of plans, monitoring, comparing the plan with the result, and based upon the result, the corrective actions were taken and further planning is done. So the same cycle repeats. This is how the planning is done in power system. Various studies in power system are load flow studies, short circuit study, electromagnetic transient analysis, stability analysis, economic dispatch, load frequency control, and harmonic analysis. So few of the analysis has been noted. The load flow analysis, short circuit and transient analysis, these plays a major role in system study. Load flow analysis. Electric power system operate at steady state mode. Basic calculation required to determine the characteristics of this state is called as load flow. Power flow studies to determine the voltage current active and reactive power flows in given power system. Short circuit studies to determine the magnitude of current flowing throughout the power system at various time intervals after fault. The objective of short circuit analysis is to determine the current and voltage at various locations of system corresponding to different types of faults. Transient stability analysis. The ability of power system considering of two or more generators to continue operate after change occurrence of the system is measure of stability. In power system, the stability depends on power flow pattern, generator characteristic system, load level, and the line parameters. Power scenario in India. So power scenario at glance all India. This data is updated on 12th of June 2023. So here the installed generation capacity as on May 31st of 2023 is the central sector has 1,55 megawatt and state sector has 1,05,726 megawatt, where private sector is 2,11,887 megawatt. On total, we have 4,17,668. The installed generation capacity as on 31st of May 2023. So the fossil fuel. So the coal installed generation capacity is 2,05,235 megawatt, which is 49 percentage of share, and gas is 24,824 megawatt, diesel is 589, and lignite 6,620. So on total of fossil fuel is 2 lakhs 37,269 megawatt. So in percentage it is around 56.8 percentage. Non-fossil fuels, or in hydro we get 46,850 megawatt, wind, solar and other renewable energies resources 1,25,692 megawatt, which is around 30 percentage, and by wind it is 42,868 kilowatt, by solar 67,078 kilowatt, by waste to energy that is 554, and small hydropower is 4,944 megawatt, so which is on 1.2%, and by nuclear it is 6,780 megawatt, which is 1.6 percentage. Total non-fossil fuel is 1,79,322 megawatt, which is 43 percentage. The total installed capacity is 4,17,668 megawatt, which comprises of fossil fuel and non-fossil fuel on total. So this is the maximum capacity. So here, this graph shows the total generation including the renewable energy sources. So as from year 2009 to 2023, it has been illustrated. So here the units are in billion units. So in the year 2009 2010, 805.4 units generation, whereas in the year uh, 2019, after 10 years it has been increased to 1389.1 billion unit, whereas in the last year 22-23 it has been improved to increase to 6 1 lakh sorry 1624.2. This is how the generation increases, including the renewable energy sources. The growth of total generation is shown here. Here from the year 2009 to 2023, 22-23 is illustrated here. You can see the growth is in an increasing order, whereas here in the year 2019-20 and 2021, here in 2021 you can see a decremental order. So you all know, due to the pandemic. So here again, and now in the again we reached the same level of 8.87. So the total growth in total generation was increased in the year 2011-12. Now again it is increasing order. So the next we are going to discuss in detail about the power system components. So the basic components of a power system are the generation, transmission, distribution and the loads. These are the major parts of a power system. So the components of power system consist of generator, which converts the mechanical energy into electrical energy. Second one, the transformers, the transfer power or energy from one circuit to another without any change in frequency. Third one, the transmission lines transfer power from one place to another. So the final one is the controlling equipment, which is used for protection purpose. So here we have the structure of power system. So we start with the generating station. So initially we have a generating station of 11 kilowatt. Then we have the primary transmission, that is we have transform step up transformer which converts the 11 kilowatt to 220 kilowatt. Next, the receiving station we have. Here in receiving station we have a step down transformer. 1 minute. Yeah, this is the receiving station. Here we have the step down transformer which step downs the 220 volt kilovolt to 333 kilovolt. And now we have the secondary transmission. Here in this substation we have step down transformer which again step down the 33 kilovolt to 6.6 kilovolt, and we can distribute directly to bulk loads in like factories and industries directly from this secondary transmission substation. Next we have the primary distribution. So here we have the feeder, and here in distribution substation here we have a transformer which again step down the voltage from 6.6 kilovolt to 400 or 230 volt depending upon the requirement, and it is then given to the secondary distribution or the distributors to the consumers and the service mains. So this is the basic structure of power system. So we have the primary transmission, next we have secondary transmission, primary distribution and secondary distribution. So this is how the structure goes on. Thank you.